Hello, my name is Michelle Stropke, and I am the Riparian and Wetland AIM Coordinator with the Bureau of Land Management National Operations Center. The following presentation will cover plot layout options within a wetland or riparian area. You can follow along in Section 4.0 of the Field Protocol for Lentic Riparian and Wetland Systems. The Field Protocol for Lentic Riparian and Wetland Systems is applicable to a wide variety of habitats that occur in an equally wide variety of sizes and dimensions. In addition, monitoring objectives for some targeted sites may focus on a specific zone of interest within a larger site. Plot layout options balance the need for flexibility with standardization. The protocol includes 4 plot layout options: the spoke layout, transverse layout, diagonal layout, and linear layout. All layouts share the same characteristics, which include 3 25-meter transects evenly spaced within the plot, a maximum area of no more than 0.3 hectares, no minimum area, and a maximum length of 200 meters. The spoke layout is the standard plot layout and should be used in areas that can accommodate a 30-meter radius circle. However, any plot layout can be used to accommodate the size of the wetland or riparian area being sampled. Plot layouts are based on the width of the riparian area or wetland site at or near the sample location. Even within the same riparian or wetland site, sample locations in different areas may result in different plot layouts. In Section 4.0 of the Field Protocol, there is a key to plot layouts as shown here. This key provides breakpoints for each layout option. If a site cannot accommodate the spoke layout, an alternate layout must be used. While the layouts are described as separate options, you can really think of the transverse, diagonal, and linear layouts as existing on a continuum from wider to more narrow sites. If a site is greater than 25 meters wide, the transects should cut across the site perpendicular to the long axis in a transverse or cross-cutting fashion. As a site becomes more narrow than 25 meters, the transects will be pitched on an angle and cut across the short axis diagonally. At less than 2 meters in width, the transects are essentially stretched linearly along the long axis. A key concept to understand with plot layouts is the option to shift the monitoring plot. When possible, monitoring plots should be centered on the sample location. However, the plots may be shifted away from the sample location for a variety of reasons, including the sample location is on the edge of the riparian or wetland area, in upland vegetation, in deep water, or on the edge of BLM-managed public land. The ability to shift a plot is very important for randomly selected sites. Most randomly selected sites are selected from National Wetland Inventory or NWI mapping, the only comprehensive wetland mapping data in the United States. Some NWI data are over 30 years old and not very precise. It is not uncommon for the boundary of the NWI polygon to be slightly off from the actual wetland on the ground. Points drawn from this mapping may be in upland areas close to wetland features. If necessary, a monitoring plot can be shifted to the closest applicable wetland or riparian area that is no more than 50 meters from the sample location. This slide shows an example of a plot that was shifted slightly to the west to be fully within the riparian shrubland. In this example, the sample location was on the edge of BLM managed land. You can see the BLM boundary in yellow. The shift allows the plot to be fully within the BLM managed land. A shifted plot does not need to be centered on or even contain the sample location. However, the edge of the monitoring plot must be no more than 50 meters from the original sample location, but the plot center can be farther. There are a few additional considerations for shifting a monitoring plot. A plot can be shifted if the shift will allow the plot to be in a wider area, but crews should minimize shifting while establishing the most efficient plot possible. If a site has a fenced exclosure, shift the plot to be either fully within or fully outside the fence. Distance rules for shifting do not apply to targeted sites because they are placed to address monitoring objectives and not for population estimates. I will now walk through each of the 4 plot layout options. First is the spoke layout, which is intended for wetland or riparian areas large enough to accommodate a 30-meter radius circle. The spoke layout encompasses approximately 0.3 hectares or 3,000 square meters. This layout includes 3 25-meter transects that radiate from the plot center with a 5-meter gap. Transects are 120 degrees apart, with the standard azimuths being 0 degrees, 120 degrees, and 240 degrees. If there is non-target habitat within the plot, the angle of the transects can be adjusted to avoid them. If this is the case, transects should be adjusted in small increments until they are fully within the target habitat, as long as they maintain a 120 degree separation. Adjust in whatever direction maintains transect azimuths as similar to the standard as possible. The transverse layout is intended for wetland or riparian areas between 25 and 60 meters in width. It encompasses up to 0.3 hectares, but can be smaller depending on the dimensions. The transverse layout includes 3 25-meter transects established perpendicular to the long axis. Transects should be spaced equidistant between the center and the far edges, and may or may not be parallel depending on the curve of the system. If the average width is greater than 25 meters, transects should be staggered along the short axis. The size and dimensions of a transverse layout are determined by the width. This table provides guidance on plot dimensions and transect spacing and can be found in section 4.2 of the field protocol. Be sure to read the footnotes in this table, which explain the maximum plot length is the length needed to achieve a 0.3 hectare monitoring plot. Minimum plot length can be shorter than the width because length is measured on the long axis and width is measured on the short axis. Any length less than the maximum plot length will result in a monitoring plot smaller than 0.3 hectares. The diagonal layout is intended for wetland or riparian areas between 2 and 25 meters in width and encompasses up to 0.3 hectares, but can be much smaller. The maximum length of a diagonal layout is 200 meters. The diagonal layout includes 3 25-meter transects that are stretched as far across the short axis as possible. Transects are spaced equidistant between the center and the far edges and may or may not be parallel. In contrast to the transverse layout, distance can be measured from either the midpoints of the transects or the ends. If a site is more narrow, it is more efficient to lay out one transect than measure the gap and start the next transect rather than measuring from the midpoints of the transect. I will show an illustration of that process in an upcoming slide. Like the transverse layout, size and dimensions are determined by the width. This table provides guidance on plot dimensions and transect spacing and is based on both the distance between the midpoints, if the transects are overlapping, and distance from one end to another. This table can be found in section 4.3 of the field protocol. The linear layout is intended for wetland and riparian areas that average approximately 2 meters in width. The minimum plot length is 75 meters and the maximum is 200 meters. This is to prevent monitoring plots that are too long to adequately sample. The linear layout includes 3 25-meter transects stretched along the long axis. If the system is sinuous, the transects may bend to stay with the wetland or riparian area, as shown in this photograph. This layout is applicable in very narrow vegetated drainages along the shore of lakes or ponds, or in a narrow zone of interest in a larger wetland or riparian area. Lastly, the protocol contains a mixed layout that is intended for wetland and riparian areas where the width is inconsistent. The mixed layout combines elements of the transverse, diagonal, and linear layouts. Draw the boundary of the monitoring plot and space the transects as evenly as possible throughout the plot. Do not spend too much time thinking through this layout. Monitoring plots in these sites are difficult to lay out. Use your best judgment and document your process. Now I'd like to present some plot layout examples. For all plot layouts, the process follows the same 6 steps. In step 1, you will locate and evaluate the sample location and shift the plot center if necessary, which is step 2. In this photo, the sample location was not in target habitat and therefore needed to be shifted into the shrub wetland habitat. Step 2 is not always necessary when establishing a plot. In step 3, determine the dimensions of the plot and choose the appropriate plot layout. In this case, the sample location could accommodate a 3-meter radius circle and a spoke layout was chosen. In step 4, determine the spacing of your transects. Determine if the standard azimuths of 0, 120, and 240 can be used, or if the azimuths need shifted to capture the target habitat. In step 5 and 6, you will establish or lay out your transects and mark the transect locations on the map. This photo shows the 6-step process for a transverse layout. This layout was chosen as it accommodates the qualifying habitat and the plot did not need to be shifted. With an average width of 25 meters and total plot length of 120 meters, the 3 transects were spaced equally 30 meters apart. In this photo, the sample location was located in upland vegetation and needed to be shifted into the vegetation drainage way. The average width of the riparian vegetation in the drainage way is 4 meters, which qualifies for a diagonal layout. The plot length cannot be longer than 200 meters, so to determine the transect spacing, the total transect length was subtracted from the total plot length and divided by 4. Giving a distance of 31 1/4 meters between each transect end. The Survey 123 form for plot characterization will help guide you through the decision process for choosing a plot layout. As you can see here, you must input the average width of the wetland or riparian area being sampled. Select your plot layout and enter the actual length of wetland or riparian area. When inputting the average width and actual length, the survey form will automatically populate the maximum plot length and suggest the type of plot layout you should use. Although you do not have to use the auto-populated suggested layout, it is helpful when deciding what plot layout may work in the sample area. In this example, the average width of the sample size is 40 meters with an actual length of 75 meters. When this information is input into the survey form, it auto-populates the maximum plot length and potential transect spacing fields. It also calculates a suggested layout, which is seen here in red text. The form calculations suggest using a transverse layout for this plot. In this second example, the average width of the sample site is 15 meters with an actual length of 200 meters. The auto calculations suggest using a diagonal layout with spacing of transects that are 50 meters apart. This concludes the methods for completing a plot layout at a sample site. Thank you for listening.